Again, looking at the series, well, a little bit confusing, but it's definitely an alternating series. I'm seeing this thing, it alternates back and forth, plus minus, plus minus, plus minus. And certainly you can do the alternating series test on it if you want. But they're asking a particular question: is it is it conditional, or is it absolute? Let me just look at the absolute value of it. And what would you get over here? Let me write that down for you. And that's 1 over n. And then I see the ln of n squared. All right, that's a positive term series. What I'm going to do now is simplify the log a little bit by bringing that 2 down. So it's 1/2 sum n equals 2 to infinity 1 over n ln n. All right. Now looking at it, you may have a different take on it, but I'm seeing this thing as an integral test. All right. Now, maybe tomorrow I'll see it differently, but right now I'm going to use the integral test. So what I'm going to do over here, let's write this down. 2 to infinity. And you get 1 x ln x dx. And I want to point out, I'll write the f of x down for you. The f of x is 1 over x ln x. And this is, positive, decreasing, and it's continuous. All right? It's positive. By the way, when I say that, on the interval where x goes from 2 to infinity, it's positive. It's decreasing, it's smaller, and it's continuous. All right? Can I integrate that guy? I think so. And let me go through that. And what I'm going to do is I'll do it on the side. I'd probably say u equals ln x. And what's du? 1 over x dx. Let me write that down for you. Put a little star here. So 1 over, well, let's see, 1 over x dx is du. And then ln x is just u. And what's it going to be equal to? The natural log of the absolute value of u plus some constant integration. All right, what's this really going to be? Ln, absolute value, wow, ln x plus c. So let's write that down. It's going to be limit as, let's see, a goes towards infinity of ln, absolute value, ln of x, and what's the limit of integration going to be? 2 to infinity. I'm sorry, 2 to a. Well, what does that give you? Well, looking at it, if a goes to infinity, the natural log goes to infinity, and the log of an infinity is still an infinity. So this thing's going off to infinity. So what do we know about this over here? This integral does not converge. I'm sorry, this integral does not converge. Sorry about that. So I know it's not absolute. I want to go for the conditional case, though. Is it conditionally convergent? So what do? I'll do that over here. I'm doing what's called conditional convergence. Let me write down the an now. But this does not converge over here. The absolute value does not, so I'm not going to say absolute convergent. What do you go over here? An would be 1 over n, ln n squared. What do I want to do over here? A couple things. One thing I'll do, limit as n, I'm using the AST test or the Leibniz test. N goes to infinity of an. Well, that's 0. That's good news. What's the next thing I want to do? That it's decreasing. So let's write this over here. 1 over n, ln n squared. And write the other term down, the one up from that. And that's going to be ln n plus 1 squared. And what do I want to show? That this one is bigger than that one over there. So let's just do that. Positive term series at this, positive terms an. What do I do over here? I guess I'd multiply both sides by n plus 1. Well, you know what? Let's just cross multiply. It's pretty easy to do. N plus 1, and then get ln. This is n plus 1, by the way. But that 2 there, I'm going to bring it down. What do you get over here? You would get 2n ln n. All right? Now, granted, I'm going to say at this point, it's fairly obvious that the left side is greater than or equal to the right side. All right, how do I know that? Well, n plus 1 in both is bigger than, n in both cases, by the way. So I'm going to say this is okay. So what do I know about the AST? This guy up here, I can now state that this is conditionally convergent, not absolutely. All right, let's look at the work. I want to point out you should be looking at the work, and I do talk about the Leibniz test, and I think I did that. I think I mentioned the conditionally convergence over here. I hope I did the integral test as well, and I did say it's infinity. So it's again the series conditionally convergence. Thank you.